Alright, we're on page 336 in our books. We're all on page 336. Alright? Alright. Let's look at what we're learning today. It says at the top, well, let's do the quick review first. Let's do the quick review. Okay? Alright. I'm going to find the quotient first, and then I'll ask you whether the quotient is even or odd. I'll say everybody for these. Okay? 48 divided by 6?
8.
Is that even or odd?
Even.
63 divided by 7?
9.
Is that even or odd?
Odd.
Odd. 9 is odd.
Oh, yeah.
20 divided by 5?
4.
Is that even or odd?
Even.
45 divided by 9?
5.
Even or odd?
Odd. 32
divided by 4?
8.
Even or odd?
Even.
Even. Alright. We're going to learn about divisibility rules today. Divisibility rules. Now, if I have a number, and I want to know if I can divide that number by another number without having a remainder, I can follow these divisibility rules. They're called rules. They're really more like shortcuts or tricks to help us find out whether we can divide one number by another number without having a remainder. Okay? We call that it divides evenly. I usually say divides easily, but divides evenly means it doesn't have a remainder. Alright? So we're going to use some rules, some tricks, some shortcuts to find out whether a number can be easily divided by another number. Alright? Without a remainder. So it gives a little story here. We've got Max there with his crutches. Must have got hurt. Okay? Poor guy. He's looking for his locker. It says Max's locker number is one of these numbers: 425, 450, 480, or 486. We know that his locker number is divisible by 2, 3, 5, 9, and 10. We have that information. We have what we know. We're going to use what we know
To find out what we don't know.
to find out what we don't know. Alright? Now, up in that blue box are our divisibility rules. In the blue box on page 336, we have a divisibility rule for each number. So, if we want to know whether a number is divisible by 2, and remember, divisible means that it can divide evenly without a remainder. We want to know if a number is divisible by 2. It says the last digit must be even. The last digit must be even. Okay, so whatever the last digit in the number is, if the last digit is an even number, you know it's divisible by 2. Okay, pretty simple, right? Simple so far. Now, number 3, for the number 3, for a number to be divisible by 3, the sum of the digits must be divisible by 3. Let me show you how that works. Let's take this number, 462. Alright? Now, first of all, is that number divisible by 2? How do we know?
Because it has an even.
Lucy?
Because it's even, all the numbers are even.
Not because all the digits are even, but because, Kate,
The last digit is.
the last digit is even. Alright? It's always that last digit you look at. Alright? But let's find out if this number is divisible by 3. Okay? Anyone think this number is divisible by 3? Who thinks it's divisible by 3? Who thinks it's not divisible by 3? Okay, we're going to find out. Alright? Here's what we do. We take each digit. Alright? 4, 6, and 2. We add those digits up. So, 4 plus 6 is,
10.
plus 2 is
12.
12. So, when we add up all our digits, we get 12. Now we have a smaller number. Can that be divided by 3 and not have a remainder?
Yes.
Yeah, it could. We can get 4, okay? But we know that that could easily be divided by 3 and not have a remainder. So, that means that this number is also divisible by 3. See how that works? Okay? You added the digits. What we did, we added up each digits. Okay? 4 plus 6 plus 2, and we got 12, right? And then we look at the sum of our digits. We look at the number that we got when we added up all our digits. And if we can divide that by 3 evenly without a remainder, then that means this number can be divided by 3 without a remainder. Make sense now? Better? Okay. Alright, so that's a little complicated, but let's look at our next one. Our next divisibility rule is for 5, and this one's a little more simple. If the last digit in the number is either 0 or 5, then the number is divisible by 5. Pretty easy, right? Cares?
Can we learn what?
Not yet. Not yet. Alright, let's look at number 9. Okay? It says the sum of the digits must be divisible by 9. Okay? This is just like 3, except we have to be able to divide the number by 9. So let's say 400, instead of 462, we'll say 468. Okay? You think this was divisible by 9?
Mm-hmm.
Who says yes? Who says no?
Okay.
Let's add up the digits and find out. Okay? We added the digits. 4 plus 6 is 10 plus 8 is 18. The sum of our digits is 18. Can 18 divide by 9 easily?
Yes.
Without a remainder? Yes. 18 divided by 9 is 2. No remainder. Okay? So, because the sum of our digits is divisible by 9, that means the whole number is divisible by 9. Same thing we did with 3. Except it's got to be divisible by 9. Okay? Question?
No.
Comment? You can make a comment.
Okay. Well, the only reason why I was confused is I was thinking we were supposed to be dividing by 8.
Oh, I see. Okay, I see. That's okay.
I understand what you're doing to get the answer, but I don't understand how it tells if that's.
I'm sorry?
I don't understand how that number can tell how the bigger number, if it can divide by.
It's just the relationship that the digits have with the number, is all it is.
So basically the process is add, divide.
For 3s and your 9s, for your 3s and for your 9s, you add up the digits, and if it's divisible by 3, if you can divide that number by 3, then the whole number is divisible by 3. If you can divide it by 9, it's divisible by 9.
Yeah, but why can't we work that the whole time?
I'm sorry, what now?
Like, here's it, 9. It says 2, 3, 5, 9, or 10.
Okay, we'll get to that in a minute. You're getting ahead of us. Let's work through these and we'll get to that. Okay. All right. Then let's look at 10. Okay. Look at 10. All right. For a number to be divisible by 10, the last digit has to be 0. That's it. If the last digit is 0, the number is divisible by 10. Pretty simple, right?
Yeah.
Okay. Now let's go back to Max. All right. His locker number is one of these. Either, and don't put this on the whiteboard, just watch. 425, 450, 480, and 486. Okay? Now look at what they did there. We're going to check for divisibility by 2 first. That's our first step. Question?
Oh, there's
Not right now. Okay. Alright, to divide by 2. Okay, so we're going to check each number to see if they're divisible by 2. We know this locker number has to be one of these. Alright. And we know it is divisible by 2. So which of these numbers can we eliminate? Which number up there is definitely not divisible by 2? There's one that's definitely not divisible by 2. Look at your divisibility rules if you need help. There's the one for 2. Okay? Stephanie?
425.
425 is not divisible by 2. How do you know?
Because it doesn't have an even number on the end.
Because the last digit is not even. So mark that one out. Okay? What about step 2? We'll check for divisibility by 5. Alright? There's one that is not, of our remaining ones, there's one that is not divisible by 5. Karis? 486 is not divisible by 5. How do you know?
Because there's no odd number there.
Not because there's no odd number there. Cadence, why?
I forgot.
Okay. Stephanie, why?
Because there has to be a 5 or 0 at the end, and that doesn't have a 5 or 0.
Doesn't have a 5 or a 0 at the end. Okay? And then, let's check for divisibility by 10. How about that? Is there one that's not divisible by 10? Is there one that's not divisible by 10? No, they're both divisible by 10. How do we know? How do we know, Delilah?
Because I have a 0.
They both end in 0. They both end in, so we got that. Now, how about divisible by 3? Well, let's look at them both. Okay? We add the digits and see if they're divisible by 3. Alright, so 4 and 5 and 0 would be 9. Is that divisible by 3? Yes, 9 is divisible by 3. How about 480? 4 and 8 is 12 and 0 is 12.
Yeah.
Is that divisible by 3?
Yep. Yeah.
Yes, 12 is divisible by 3. Yep. So they're both divisible by 3. Alright? But let's look at the last one. Let's see if they're divisible by 9. Alright, so 450, 4 and 5,
9.
and 0 is 9. Is that divisible by 9?
Yeah.
Yes. How about 480?
No.
4 and 8 is 12, and 0 is 12. Is that divisible by 9?
No.
No. Okay? So, his locker number must be 450. Very good. Okay? How about you close the door now? Okay. Let's look at some examples. Alright, that was a lot of thinking went into that. Alright. A lot of thinking went into that. Let's look at some others that are a little more simple. Let's look at number 2 on page 337. Number 2 on page 337. Do this on the whiteboard. Okay? And use your divisibility rules. But we'll do this one together. Use your divisibility rules to see if 96, so write 96 on your board, and tell whether it is divisible by 2, 3, 5, 9, or 10. It can be more than 1. It can be more than 1. First off, is it divisible by 2? Is it divisible by 2? How do we know, everyone?
Because it has an even number.
The last digit is even. Okay, so it's divisible by 2, so write 2. Okay. How about 3? Okay, so to find if it's divisible by 3, we add the digits. 9 plus 6 is?
15.
Is that divisible by 3?
Yes.
Yes. Okay, put a comma and put a 3. Okay. How about 5? Is it divisible by 5, everyone?
No.
No, it doesn't end in a 0 or 5. Okay, let's move on. How about 9? Okay, remember we added our digits and we got 15. Is that divisible by 9?
Yes.
15 is not divisible by 9. Nope, nope, nope. Alright, how about 10? Is it divisible by 10?
Nope.
How do we know?
Because it's not even 0.
It's not in a 0. Okay, so what numbers is that divisible by, everyone?
2 and
2 and 3. Okay, see how we do that? How about number 8? I'm sorry, not number 8. Number 3. Number 3. Alright,